Hello dear students, from today I will start your maths class through my video. Okay, so first unit is calculus, integral calculus, evaluation of definite integral and improper integral, then reduction formula, beta gamma functions and applications. These are the topics of first unit. So here I will start now. Evaluation of definite integral. Evaluation of definite integral. Just you have already familiar with definite integration from your previous class. I know. Okay, but just some brief discussion about definite integration. Okay, definite integral. Definite integral. Just we know the indefinite integral. You know. There are many formulas for finding the integration of some function. Okay, so definite integral is indefinite integral is a function of x. Okay, function of just in terms of variable of integration. Okay, but definite integral have a unique value. I have a definite value because in definite integral, just we know. In definite integral, here I will discuss about definite integration. What is definite integration? How can you find the definite integration? Just you have already studied about it, but here a different type of typical integration, definite integration, we will require in the engineering problems, in higher classes also. A Laplace transform, Fourier transform, all are related to integration. Okay, there are limits with the proper integral, also improper integral. Improper integral means having limit infinity. Okay, and also their definitions are different type of tests are there for finding convergence and divergence of improper integrals. So here just we have to find just discuss about how can we find the value of definite integration. Definite integral, we know the definite integral just like this, fx dx, that is integrand is here and we give to limit. This is the lower limit, this is the upper limit. Its value is a definite value. Okay. If we omit this limit, then this is indefinite integral. By solving this, we can get a value in terms of x. Okay. When apply the limit, then its value is definite value. Okay. So, how can we find this definite value? That is, evaluate this integral. So, for that, there are many methods. First of all, just first definition for evaluation of definite integral just evaluation of definite integral. Okay, so first of all, we for evaluation process, there is first definite integral as a limit of sum. Second, using fundamental theorem. Integral using fundamental theorem of integral calculus. Using properties of definite integrals. Okay, and also for definite integration by substitution. Means this type, first of all, because definite integral as limit of sum, this is our first step from where we are getting definite integration. After getting this formula and we relate this definite integration with indefinite integral. Just this is indefinite integral, suppose. This is suppose indefinite integral. And its value is another function fx. Okay? So its value is defining as indefinite integral, we know integration of this function is another function of x with some constant. Okay? When we apply on limit on this, its derivation from this limit of sum, that is different thing, and this is different thing. Later on, it will see that if we apply limit on this, then from limit of sum, as a integration as a limit of sum, we get result. That result is same as if we apply limit on this, just like a to b. It means if its antiderivative is this, then if we apply limit on this, then we can means b first limit. So fb plus c minus fa plus c. So we can get fb minus fa. This is also called second fundamental theorem of integral calculus. Second fundamental theorem of integral calculus. So by this we can also find the value of definite integration. And this provides easy method, easy process, because we know the integration of function, there are many formulas. Just you can find the fx and just apply the limit from fb minus fa, that will be the value of definite value. Also we can find as a limit of sum, that is this process of this is very tedious, okay, for typical functions. So we use this by using fundamental theorem of integral calculus. This is fundamental theorem. This is equals to this. When fx is closed, fx is continuous on closed interval a. If then this is fundamental theorem of integral calculus. Clear? Using this we can get the definite value of we can evaluate the definite integral. Okay, by using properties, just we know there are some properties are having with this integral. Just we can just I will summarize now all the properties, because properties are very important for finding the definite value of definite integration. Okay, so here definite integration can find by this, or using properties, and also definite integration by substitution. for finding the integral, suppose just x e to the power x square dx. Okay, and if limit we apply like this 0 to 1, then you know how can you solve it. But there are process. Just first of all, without limit you have to find the value of this as a definitive, fx as a indefinite integration. Then after then you can apply limit, or just you can use substitution here also as the method integration by substitution, because you can, and just substitution and evaluation of definite integral with simultaneously you can do by using definite integration by substitution, because here variable will be changed in another form and limit will also change for this. Okay, this provides also easy method. Okay, so by any of this we can find the value of definite integration. Okay, so all the previous formula which you have already studied in the previous class, just you have to remember always. So also this is a first class, so just remember that you have to keep prepare a copy for mathematics. Just I will give some questions through my lecture, video lecture, and that questions you have to do in your math copy. Okay, and after some days, as I will request to you to send the PDF file to me for of your homework copy. That will be your, just you can treat as a assignment. Okay, so in each video I will give some questions you have to do in your copy always. Okay, whenever I will ask for sending, just you have to send. Clear? So here in this lecture, just we will do some questions, 2-3 questions for finding typical integration, definite integration, and some of the questions I will give for you. Okay, so here just substitution. For substitution here you can see that what all of you can do it, but practice is very important for mathematics class. Okay, for mathematics, so just you can do by substitution, direct substitution. That means x square equals to, you can put t, so 2x dx equals to what? Dt. So x dx equals to what? Dt by 2. And here also, if we put x square equals to t, then t is the new variable and t limit of t is will be, this is x equals to 0 is here. So x equal to 0, t equal to 0. So x equals to 0 provides t equals to 0. Similarly, x equals to 1 gives what? Y equals t equals to 1. You can get from here. So limit is also changed for direct using substitution. As a definite indefinite integral, you can also do it. Just fb minus fa formula can be used, fundamental theorem. So here just use this, x equals to 0, t equals to 0 to t equals to 1. So what? 0 to 1 here also. So x dx equals to what? Dt by 2. So dt by 2 and e to the power t in place of x square t. Just we know 1 by 2, 0 to 1, e to the power t dt. What? Integration e to the power t. Just apply the limit 0 to 1, 1 by 2. Okay, e to the power t, integration of e to the power t, e to the power t. So 0 to 1, so 1 by 2, e to the power 1 minus e to the power 0. So what? Half e minus 1. This is the value. This is direct using substitution. So there are different methods for solving definite integration. Okay, so properties of definite integral are very important, because in further in higher classes you will face with integration, with definite integration, with limit. Okay. Also here these are if whenever these all are proper integrals. If here just I'm saying that the integration is this dx a to b. If a b are finite numbers and fx is bounded in this closed interval. Fx is defined in closed interval and fx is also bounded in. Then this is proper integral. Just analogous to Riemann integration. Okay. So proper integration. Proper integral. And improper integral. What is improper integral? If function is not bounded, there are three types of improper integral. First improper integral of first kind. If any of this limit either a equals to infinity or b equals to minus infinity or both are infinity, then the integration is known as improper integral of first kind. Improper integral of either of a is infinity or b is infinity, maybe this is minus infinity, this is plus infinity, or both are present here, just like this. 0 to infinity, just like minus infinity to 0, just like minus infinity to infinity. This type of limits, if we are having, then improper integral of first kind. And if limits are finite but function is unbounded, is bounded, then proper integral. For improper integral, unbounded function at any of the point, unbounded in at any point in this. So improper integral. This second kind of improper integral where limits are definite. But these are if either of the limit of infinity, first kind of improper integral. Okay. So this is second kind of improper integral. This is first kind of. First kind means either of this limit are infinity. First kind of improper integral. And if limits are finite but function is unbounded, then function is unbounded at any point in this interval. Then this is second kind improper integral. Second kind improper integrals. If both type of first kind and second kind mixing type, function unbounded and limit is either of the infinity with having infinity, then third kind of improper integral of third kind. So this type of integration are also we have to solve. Okay, there are many tests for testing whether integral is convergent or divergent. Convergent means you can find the value. Okay, so just today I will discuss about proper integration. That is, function is bounded in closed interval and have a definite value and limits are definite values. Okay, so just 3-4 types are there. You can find the value of definite integration. Just like see, suppose we are having x cube dx. Just first of all, I will discuss in brief the properties of definite integration. Okay, one by one. So here properties, properties are very important for solving definite integration. There are properties. Just I am providing this list of definite properties of definite integrations. You have to remember it always. Okay, so we will use this any of the property at any stage for evaluation of the definite integration. Okay, first property, what? A to b fx dx equals to, means a variable. This is first First property means f as dx, ft dt. A to b, a to b, limit are same. That variable can be written like this. In place of x, you can write t, u, b, etc. Okay. Second property is what? If a to b is limit, then b to a. If we change the limit, then just minus sign is the front side. Just here f as dx, here f as dx, f as dx. Okay. If limit is changed, the upper to lower, lower to upper, then minus sign is there. Okay. Third, if in this interval there is a in between point C, then we know a to b can be written as a to c plus c to b. Okay. And fourth property is what? Fourth property is we know a to b fx dx is equals to a to b fa plus b minus x dx. This is fourth property. This is the general property. Its particular type is very, very important here. You can see the property. Okay. So its general part. That means this formula is mostly used. Just like this. A to b f x dx equals to, this is general property. What? F a plus b minus x dx. You can prove it. Very simple. Just put this is equals to t, and then by using previous property you can see that same as a to b f as dx. Okay, its particular form is what? If a equals to 0 and b equals to a, then 0 to a fx dx is equals to what? 0 to a fa minus x dx. It can be proved by this is equals to t, putting, and its particular type is this. If a equals to 0, then 0, 0, 0, here b, in place of b, you just write a. This is important property. Okay, important property. Just mostly we use this formula. Okay, and then the next property is here for limit 0 to a, 0 to 2a fx dx. It can be written as 0 to, just the property is zero to a fx dx plus 0 to a f to a minus x dx. Okay. This is, it can be proved. Okay. So here, by using this, we can get formula. It can be proved. Also, you know, if you, in this second integral, if we put this is equals to t, then after combining it, we can get remaining just like this. We can also here use for proving, just you can refer your previous class material. Okay, here just to it, its particular type. Now, if this is equals to fx, then same type of two integral two times. So here you can see that this is equals to 2 times of 0 to a fx dx. If f to a minus x is equals to fx, and 0, if this is equals to minus fx, then this will be cancelled 0. If f to a minus x equals to minus fx. Very, very important property it is also. Okay. So 0 to 2a, because for solving definite integration, limit should be, is our choice. So for changing the limit, here 2a, here a, So we can use this formula. Now, final formula is another formula that is also important, even odd function. In case of even odd function. Okay, in case of even odd function means just if we have limit like this minus a to a fx dx, then if fx is even you know, even means what? F minus x equals to fx, that is this. And if f minus x equals to minus fx, that is odd function. This is equals to what? In case of even 0 to a, the limit is changed. Will change minus a to a, 0 to a. 2 times of 0 to a fx dx. If this, and this is 0 if odd function. So this is also important. So there are three important formula. What? 0 to a f a minus x, and another 0 to 2a, 2 times of 0 to a f to a minus x equal to fx, and f to a minus x equal to minus f, then 0. And this is formula minus a to a. 2 times if even, 0 if odd. These three special type of properties are frequently used for finding the values of definite integral. Just you must practice for doing integration using these properties. Okay. So for example, here just suppose we are having integration just like this, integration x cube dx, 0 to 1. This is an integral, and we have tried, we'll find the value of this integral. So you can find this its value by using limit as a sum, by using property, by using fundamental theorem. Okay. First, if we want to find the value of this by using limit, integration, definite integration as a limit of sum, then we know formula for a to b fx dx is equals to what? B minus a limit n tending to infinity 1 by n f a plus f a plus h plus a plus 2h plus and so on f a plus n minus 1h. This is definite integral as a limit of sum formula for, you know, from your previous class. So this integral can be found by any of the three methods. For not using substitution, just I have given another example here. By using limit, definite integral as a limit of sum, that is the formula here. Clear? Here h, in this case what we have to do, just interval is dividing as equal part h, equal interval here a to b, just divide in n parts, then a plus h, a plus 2h, a plus 3h, a plus 4h are the points. At that point the value of the function is fa plus h, fa plus 2h, fa plus n minus 1h up to the this interval. Okay, so first value is x0 equals to a and last value is xn, then this. Okay, a plus 0h, so final value is a plus n minus 1h because n part are there. Now this is the formula for definite integral as a limit of sum. By using this formula you can get its value. By using fundamental theorem it can you can find this value. By using property, you can get its value. Just see here. By using this formula, how can you get it? Here B, here the B minus A by N is equals to what? H. H equals to, how can you find the value of H? B minus A upon N. This is the formula. Well, okay. For these questions, here A equals to 0, B equals to 1. Therefore, H equals to what? B minus A by N equals to what? 1 minus 0 by N equals to 1 upon N. H equals to. Okay? Now, by using this formula, you can write it as what? B minus A, that is 1 minus 0. This is Fx. This is Fx. And here Fx equals to what? Fx equals to x cube. Fx equals to x cube. So, just you can see B minus A, limit n tending to infinity, 1 by n, first value Fa, A means 0, plus second value Fa plus H, that is 0 plus H, plus F 2H, 0 plus 2H, 3H and so on, and up to F n minus 1H. What? 0 plus n minus 1H. This is the value. Okay. Now, this equals to 1, 1. Limit n tending to infinity, 1 by n. You can write F0 by this formula. What? Zero plus H Q plus 2H Q plus n minus 1H Q. This. Okay? Now, here we see that limit n tending to infinity. Clear? So, 1 by n. Now, either you can convert n to h or h to n. So here h, so h cube, h equals to what? 1 by n. So 1 by n cube plus 2 by n cube plus 3 by n cube plus and up to what? N minus 1 by n cube. This. So you can get what? Limit n tending to infinity, 1 by n. Here you can see that q are at each term. So n cube denominator can take outside. So we get 1 cube plus 2 cube plus 3 cube plus up to n minus 1 cube. Just use the series, from previous class. This is equals to what? Sum of n terms, 1 plus 2 plus 3 plus n minus 1 by 2 and up to n terms. And square, also sum of square, sum of cubes are what? N minus n plus 1 by 2. If terms are 1 plus 2 plus 3 up to what? N. What? N plus 1 by 2. This is formula. Square, cube formula. Up to the n term. Here. If in this place just we use what? N minus 1 cube. Up to the term n minus 1 cube. So in place of n, we have to write n minus 1. N minus 1 in place of n, or here n n minus 1, 1 cancel n. So n minus 1 by 2 square. So you can use here limit n tending to infinity 1 by n power 4. Here what will be the value by using that formula? n minus 1 by 2 square. Now from here we can see the value 1 by 2 square means 1 by 4 is this. Okay. Now limit here n square, just taking common for 1 by n power 4 n tending to infinity, just you can set it. Okay, 1 by 4 is outside, so here n is common, then n square 1 minus 1 by n is this. Just take common n square 1 minus 1 by n. Now here n power 4 n square 4 cancel, n tending to infinity 1 by n tending to 0, so 1. So this is equals to 1 by 4. So its value is 1 by 4 by using definite integral as the limit of sum. So this is tedious method, okay. So that's why we use another method, fundamental theorem. What is fundamental theorem? Its answer is what? 1 by 4 by using this method. Just see by another method, fundamental theorem. You know fundamental theorem is what? Second fundamental theorem. If we know its antiderivative. Antiderivative means just integration. If integration of fx dx is equals to fx. Okay, we can take constant term or cannot take, because after applying the limit constant will cancel. So if this, then it means what? Indefinite integration. Then limit a to b fx dx equals to what? Fb minus f. This fundamental theorem. Fundamental theorem of integral calculus. Second. Okay. So here without limit, just you have to find the value first of all. Without limit. Without limit, since integration of without limit x cube dx is equals to, you know what, x power 4 by 4. Since this without limit, this, that is capital Fx equal to this, that is capital X. Therefore just apply the limit x cube dx is equals to what? F 1 minus f 0 by using this. So f1 means 1 power 4 by 4 minus 0 power 4 by 4 equals to 1 by 4. This is the answer. So it's the same answer, 1 by 4. So using what? Fundamental theorem of integral calculus. Okay. So just in 2-3 steps we can get the result using a limit of sum. So very lengthy method. Okay. Now third is by using property. By using property we can also find value or no, not here property is not required. Just like this, suppose for integration minus 1 to 1 x cube dx. By using this theorem we can find limit what? X power 4 by 4 or minus 1 to 1. So we can see that what? Value 1 power 4 by 4 minus of minus 1 power 4 by 4. So this is equals to 0. But by property we can find its value. Minus a to a, this is odd function, because you know x cube is odd function. What? F x equals to this. The f minus x equals to what? Minus x power 3 equals to what? Minus x cube equals to minus fx. odd function. Due to odd function, this is equals to 0. You can say direct. But by fundamental theorem, you can also see that its value is 0. So, there are different type of technique for evaluating the definite integration. Just we will choose the method which is give easier process. So, most of the time we will use the properties for evaluation of definite integration. Okay, so take some of the questions from just also say modulus technique. Okay, for finding the value of integral, the mod here, just see, take questions, evaluate integration of -1 to what? -1 to 3 by 2. -1 to 3 by 2 mod of sine x sine pi x. Sorry. This is the question. Mod of x sine pi x dx. 3 by 2. Evaluate this integration, definite integration. Okay. So how can we solve this integration? Modulus. If there is modulus function is used in the integrand, first of all you have to remove this mod by using the definition of modulus function. Okay. Here integrand fx is equals to what? Mod of x sine pi x. Its value can be right in this interval -1 to 3 by 2. -1 to 3 by 2 means here -1, 1, 3 by 2. These two intervals are used here just because sine pi x. So if x lies between -1 to +1 here in this interval x in this interval, then just we can use -1 to x to 1. Here pi x we require. So minus in place of pi x. So minus pi less than pi x less than pi x is less than pi. Minus pi to pi, this value. Minus pi to pi. Minus pi to pi means here pi is this interval. In this interval, x and this multiplication will be what? Positive value gives, because in this part 0 to pi part sign is positive and value x is also positive in this part. In this part x is negative and sine pi x is also negative. Minus pi to 0, if opposite direction in this part. So here sine is negative and x is also negative, so positive. So in this total, its value is positive. So we can write x sine pi x as positive if x lies between minus n to plus 1. Clear? -1 to plus 1. And in this interval, at 1 less than x less than 3 by 2, so just multiply pi in 3, pi x is less than 3 pi by 2. Pi to 3 pi by 2. That is what? Pi to 3 by. This is pi, this is 3 pi by 2. Here, sign is negative. So this is negative. But x is positive. So positive, negative, negative. So in this interval, its value is minus x sine pi x. If 1 less than x less than 3 by 2. This is the breaking of this mod. Now we can solve integration. Okay. So very simple. After breaking this mod, just we can write, therefore I equals to what? Minus 1 to 1 mod x sine pi x. Just we break this mod in this interval by using property was what? A to B to A to C, C to A. By using this property, we can write where C lies between A to B. So here minus 1 to 3 by 2, in between number is 1. So by using this property, we can write this plus 1 to 3 by 2 my mod of x sine pi x dx. Okay? This. So this is equals to, in this interval, you can take minus 1 to 1 x sine pi x plus here 1 to 3 by 2, its value is with minus sign. So minus x sine pi x dx. Now we can solve it. Okay, its integration is what? First integration, x sine pi x. How can you integrate it? By parts. If you use by parts, then this x will be first function, this is second function. The second function, that means minus integration by parts. By fundamental theorem, we will use just different integration. It's independent integrals, just put and apply the limit. Okay, minus 1 to 1. So here sine minus x, first function cos pi x upon pi, minus plus what? Sine pi x by pi. Just using by parts here, we can get like this. Okay, minus x cos pi x by pi plus pi. This is pi square. This will be just applying by parts. And here minus sign, and just integration of this is same. So minus sign is outside. So here minus x cos pi x by pi plus sin pi x by pi square. Okay, sin pi x by pi x square. Just apply the limit. Apply the limit means first put x equals to 1 and then x equals to minus 1. Sin pi equals to 0, you know. So apply limit here and also here 1 to 3 by 2. The limit will be 1 to 3 by 2. Okay, so you can get result. Just apply limit minus 1 to 1, 1 to 3 by 2. So the value will be what? Here. After 1 cos pi minus 1 sin pi 0 minus 1 minus plus 1 by pi at the time of minus 1 cos minus pi also minus 1, minus minus plus, and this will give its sign will plus. So 2 by pi. So 2 upon pi. Here you can see sin pi 0. And second value will be minus of minus 1 by pi square. And just you do it. Okay. 1 upon pi. And you can write the answer. 2 by pi minus 1 by pi square minus pi, and result will be 3 by pi plus 1 by pi square. 3 by pi plus 1 by pi square. Just do the calculation here by putting the value, you can get the value. So modulus, in the case of modulus, you have to break first and divide the interval by using the property, and you can solve it. So this is the answer of this question. Okay. Now take another question for evaluating definite integral, because definite integration, evaluation of definite integration can be done by using any of the technique. Just first of all, just identify which type of integration is given, which method will be suitable, either by properties or by substitution or by using any of the properties. We have to find the value of integration. Okay. There are many formulas of integrations. Just revise all the formulas. Okay. Now take another questions for evaluating definite integrations. Just I think for to be expertness in the solving definite integration, we have to practice at least 10 questions every day, because there are many questions in any of the mathematics book you can see. So here just for this M1 subject, you can use the book having many questions, but the important book is Dr. B.S. Grewal by B.S. Grewal book, Tata McGraw-Hill, B.V. Ramanna, H.K. Das. You can use. Also, you can get many questions from other books. But you have to give one book that will be your basic book, and all the questions from that book you have to solve. Just try to solve. Okay. And all the questions which I will give, you have to solve in your copy. Clear? And also write always different type of formulas, then you can get the expertness in solving definite integration. Okay. So here just take a questions a square cos square x plus b square sin square x 0 to pi. So here this is the question, the very important questions. Okay. So evaluate, because this is higher classes than 11th 12th. So the integration, the quality of questions will be some higher level from the school. So evaluate definite integral just like this, 0 to pi x dx. But these topics, evaluation of definite integral, this is from your school topic. Just you have to revise very well and do some questions. So here a square cos square x plus b square sin square x. This question is given. You have to find this value. Okay, x dx. b square sin square x. So by which method we can solve it? Maybe there are different methods, but by using properties we can solve it. Okay, so let us try to solve this. Okay, so use here for this integral. Suppose this is I. Okay, evaluate this integral. So I equals to, here first of all you have already seen that in the case of definite integration, just a property, this property is used, frequently used. Fx equals dx equals to 0 to a f a minus x dx. Clear? This property is very useful property. By using this, just for integrating this, we know whenever from our integration process, whenever the denominator or numerator both are containing the terms sine and cos with same power, then we can divide in numerator and denominator by cos square or either sine square. Then you can convert it in a form that can be easily integrated. So here just having cos square sine square, but here x. So for removing this x, we can use this property. Just like just use this property. Okay, this is the property of star. Okay, suppose star. So using here 0 to pi minus x. Just we see that here in place of x we write a minus x. A minus x means this minus x. So here pi minus x in place of x, pi minus x dx upon just a square cos square pi minus x plus b square sin square pi minus x. In place of x, just we have to write only pi minus x using star. Clear? Now, here we see that I equals to cos pi minus x cos x. Because of a square, so sine may be anything. Cos square pi minus x means cos square x. Sin square pi minus x means sin square x. So just differ from here. Pi minus x dx upon a square cos square x plus b square sin square x dx. Okay, this. Now I equal to this, I equal to this. Can we add? And this denominator are same, so numerator will add. So x plus pi minus x, x cancel, we will get only pi. So this is equation 1, this is equation 2. Adding 1 and 2, we get what? 2i equals to 0 to pi, limit same. So x cancel, pi, only pi dx upon a square cos square x plus b square sin square x. Okay. Now for solving this integral, here pi can be taken outside. So we can write like this. I equals to pi by 2. Adding this to I plus I 2i, this plus this gives this 2i, I equals to, I is our record integral. So I is equals to, here pi outside, so pi by 2, this. Now we can write 0 to pi 1 upon cos square x plus b square sin square x a square dx. Now here nothing is here. Now we can divide numerator and denominator by cos square or sin square. and we can get in terms of tan and sec, cosec and cot. Here, one thing is that this is interval pi. If we convert it in either in cos or in tan, then for applying limit, there will be some problem, I think. So we can use by a property for converting this limit as pi by 2 generally, because in case of 10, if we can get this limit as pi by 2, then for solving that it will be easy for us. Okay, so here just we have to brackets limit, means we can use the formula also 0 to 2a fx dx is equals to 2 times of 0 to a fx dx if what? If 2a minus x equals to fx, and if f 2a minus x equals to minus fx, this is 0. So we can use this property 2a. Just consider like this, pi by 2, 0 to 2 into this pi can be written as 2 into pi by 2. 0 to 2a, pi can be written 2 into pi by 2, 2 cancel, 0 to pi. So it can be written like this, 0 to 2a. And here 1 upon a square cos square x plus b square sin square x dx. Okay. Now, using this property, suppose this is double rational property. We know this and this. By using this property, we can see this is our fx, and here this property will follow, because f 2a minus x, 2a minus 2a, 2a means this what? Pi. 2a means pi. So pi minus x. If we put here pi minus x, pi minus x, then this will be true, because this will give same value if we put x equals to pi minus x. So by using this property, this can be written as 2 go to the outside and 0 to pi by 2, limit will change. Okay, so here after this line we can write, I equals to what? Pi by 2 into 2 times of 0 to pi by 2. 0 to pi by 2. Okay? 0 to pi by 2. 0 to a, 0 to a, by using this 1 upon a square cos square x plus b square sin square x dx using double star. Okay? Now this is equals to pi. Now 0 to pi by 2 plus 0 to pi by 4, pi by 4 to pi by 2. Just break this integration because using the rule what? A to B fx dx equals to A to C plus C to A. This clear? By its division is required because for getting values it will give easy process. Now here 1 upon what? A square cos square x plus b square sin square x. Here a square cos square x plus b square sin square x. Just by using this property, break 0 to pi by 2 in between number pi by 4. Now here pi. Now just divide numerator and denominator by here by cos, here by sin, because for finding limit at pi by 2 of 10 will give infinity value, so we can use cot, values for cot. Okay, so here cot, how can you get cot? Just divide by sin square x. In this integral, numerator and denominator divide by cos square. In this integral, divide by numerator and denominator by sin square. Here you will get cots. Just like this. Suppose here divide 1 by cos square, numerator and denominator divided by cos square. So 1 by cos square sec square. So sec square x dx upon here divide by cos square. A square plus a square into cos square by cos square cancel. So a square plus here b square sin square by cos square 10 square. So b square 10 square. 0 to pi by 4. Clear? So just this pi is outside. This. Okay? Plus here just numerator and denominator divided by sin square, because for finding limit at this point 10 will give infinity, so here cot we can change it in cot. So divide numerator by denominator by sin square. So 1 by sin square cosec square x dx upon here by sin square. So a square cos by sin cot square and plus b square, and limit pi by 4 to pi by 4. Now we have to solve this two integral. Okay, so for solving this integral, just we are using these three properties also. Now many formulas are used, will be useful. So here, if in short, just I remove this part now. Okay, now I will write substitution. For doing this integration, just what you have to do here just write 10x equals to t, then you can get sec square x into differentiation of sec square x, and cot x equals to some other variable u, then you can get minus cosec square x. So substitution. Put tan x equals to t in first integral and cot x equals to u and cot x equals to u in second integral. Okay, so here tan x means differentiation sec square x dx equals to dt, and here minus cosec square x dx equals to du. Also x equals to 0 gives t equals to 0, x equals to pi by 2, t equals to, give what limit? So here not pi by 2, not pi by 4, pi by 4, give t equals to 1, so 0 to 1. So first, in first integral, limit 0 to 1, and here sec square is dx equals to dt, so dt upon a square plus b square t square. This is first integral by converted by this substitution. Similarly, here just minus sign cos square dx minus du, so minus of du upon a square u square plus b square, and limit will be what? Here x equals to 0, not 0, sorry, x equals to pi by 4. Pi by 4 implies u equals to, what pi by 4 is also 1, and x equals to pi by 2. X equals to pi by 2. Then u equals to 0. U equals to what? 0. And minus yet 1 to 0. This is the converted integral. Now here we can see that pi in first integral, if we take common a square, so 1 by a square integral 0 to 1 dt upon 1 plus b by a t square, and in second integral, just if we write plus sign here, then we can write 0 to 1. By 0 to 1, here common is what? b square. Just take, because 1 to 0, just by property you can use 0 to 1, then sign will be negative, positive. So 0 to 1 and 1 upon b square is common. Then what? du upon 1 plus a by b u whole square. This is our converted integration. Now we will use the formula for getting final value. What will be the formula for this? Just 1 upon 1 plus x square, integration of, we know, integration of 1 upon 1 plus x square dx is equals to what? Tan inverse x. But whenever then here, if x having some coefficient, suppose here just like this ax square, then what will be the value? Divided by a. Divided by a. If x having coefficient, due to integration process, we know, na? So here, this is main formula. We know this. So use this formula here. We can get I equals to what? Pi in first 1 by a square, just in this integral, tan inverse b by a t, bt by A upon B by A. This. Similarly, 1 by B square here, tan inverse A by B U upon A by B. In this, just you have to apply limit 0 to 1. Here also you have to apply limit 0 to 1. Okay. Now you can get the result. What? A 1 by A, 1 A cancel, 1 upon AB, 1 upon AB, and here tan inverse B by A by putting 1 and 0, 0 minus 0. This is first value. 1A cancel AB. Here 1B cancel AB. Tan inverse A by B by putting limit 1, and by putting 0. This is our result. Now we can find its value, okay, by using formula. Here just this implies 1 upon integration of 1 plus ax square is equals to tan inverse ax by a. This formula. And also now we know, just like this here, see pi by ab is common. Now we get tan inverse b by a plus tan inverse a by b. This can be written in short. We also know that tan inverse x plus cot inverse x equals to pi by 2, and cot inverse x equals to tan inverse 1 by x, or tan inverse x equals to cot inverse 1 by x. Just we know. So here use this pi by ab, this tan inverse b by a, plus here we can write what? This can be written as cot inverse b by a. So same thing, tan inverse b by a plus cot inverse b by a. Tan inverse x plus cot inverse equal to pi by 2. This is equals to pi by 2. So pi square by 2ab. It can be written as pi by 2. So pi square by 2ab. So answer is what? Pi square by 2ab. So this is our solution, the value of this integral. Okay. So in these questions, many of the properties and formulas are used. These are trigonometric, inverse trigonometric formula. Okay, and integration formula, and many of the properties are used. So typical integration can be solved by using properties, formulas. That's why you are just write all the formula in your copy also, and remember formula, and try to do some questions, okay, for evaluating definite integral. Now take an very important questions, okay, just very interesting and very important questions, definite integrations, the special type of definite integrations. So we have to solve these questions also. So here just question is, Evaluate the integral alpha to beta, x minus alpha, beta minus x is there. Okay. So just in the time of evaluating the indefinite integral, we have used the integration take a small questions by just using improper integral just like this. Okay, e to the power minus x dx. I think all of you can solve this. Whenever limit are having infinitive, just you cannot put the infinitive as a value. So for that, how can we find the value? This is equals to, just by using fundamental theorem we can do integration without limit, what? Minus e to the power minus x, and use limit 0 to infinity. This limit, just you cannot put the infinitive in this place. Here minus is outside, just we have to write like this: limit x tending to infinity e to the power minus x minus outside e to the power minus 0. 0 is definite value, so you can write it. And now this limit x tending to infinity e to the power minus x minus e to the power 0, that is 1. So this is equals to what? Limit x tending to infinity e to the power minus x minus 1. Okay, minus of this. For finding this limit, e to the power, first of all, if something power negative with variable and variable tending to infinity, then you have to write it as with positive power. That means minus x tending to infinity 1 upon e to the power x minus 1. And now minus can be inserted here. So 1 minus 1 plus 1 minus limit x tending to infinity 1 upon e to the power x. This is 1 minus 1 upon limit x tending to infinity e to the power x. Okay. This tending to what? Infinity. How? E to the power x equals to 1 plus x square plus x cube plus and so on up to infinity. We know. Just use the x upon 1 factorial, x upon 2 factorial, x upon 3 factorial. So here we see that if x tending to infinity, then here x is in the numerator. So e to the power x also tending to infinity. So this tending to infinity. So 1 minus this tending to infinity means 1 by infinity 0. This is equals to 1. So this integral is equals to 1. Just for improper integral finding integration like this. Okay. How can you find the value at infinity? So just follow the process for finding limit at infinity. Okay. So this is simple type of improper integral. Okay. So here just take a question for evaluate integral alpha to beta integration alpha to beta dx upon root over alpha minus x, no, x minus alpha, I think. X minus alpha. Just take x minus alpha and beta minus x. This integration, beta minus x. Okay, now for solving this integral, just remember the for the indefinite integration. Remember for the indefinite integration, how can we solve this integral? 1 upon ax square plus bx plus c dx. Just just write this integral 1 upon root over either a square minus x square or 1 upon root x square minus a square. We are having formula. So just this second degree power, just up by writing as a perfect square method, we can write a square minus x square or x square minus a square in this form. So this integral is what? Sin inverse x by a, its value. Okay, so using this formula, we will use this formula. Okay, first of all, we have to convert second degree factor to the form a square minus x square or x square minus a square under the square root sign. So here, for solving this integral, this is equals to, we can write alpha to beta. Now dx upon, what we can write? Just multiply it. We can see that minus x square plus alpha beta, minus plus alpha beta is here. So plus alpha x plus beta x minus alpha beta. Just after multiplying, we can get like this. So this is equals to what? Alpha to beta dx upon, how can we write it? Under square root, just minus x square plus alpha plus beta x minus alpha beta. This is second degree factor. It can be written as a square minus b square, a square minus x square, x square minus a square. So here we see that whenever having minus sign with x square, just take minus sign common. So here just we can adjust like this. If we take minus sign common, then x square minus alpha plus beta x and plus alpha beta, just like this. Okay. Now for doing alpha, here we can write like this. Suppose minus alpha beta is outside now. Okay, minus alpha beta outside. Then x square minus 2 into alpha plus beta by 2 x plus alpha plus beta by 2 square. Just for setting, we have write like this, minus alpha beta outside. Now minus square like this, alpha plus beta by 2 to cancel alpha plus beta. This can be written like this. So x square minus 2x, this is b. This a square minus 2ab plus b square. So b is this. It is adding here. Also subtracting. Also minus subtracting. Alpha plus beta by 2 square. Just we can adjust like this. Now this minus plus, you can take it outside. You can take it outside. So here what will be? Alpha plus beta by 2 square outside. Then you can omit this. Okay. Now this is equals to this. So here we can write x minus alpha plus beta by 2 whole square. X minus alpha plus beta by 2 whole square. Now here in this part we can see that here alpha square plus beta square plus 2 alpha beta upon 2 minus alpha beta, just this first part minus alpha beta, and taking LCM we can see that here what alpha square plus beta square by 2 plus alpha square plus beta square by 2 taking LCM, then alpha square beta square plus 2 alpha beta minus 2 alpha beta. So this cancels alpha square plus beta square by 2, alpha square plus beta square by 2. So here also 4 is this, sorry, this is 4. So this is a square 4 minus 4 the 2 alpha beta minus 4 alpha beta. So it can be adjusted like this, what, minus 2 alpha beta. So here we can see that alpha square plus beta square minus 2 alpha beta. So alpha minus beta upon alpha minus beta by 4 2 whole square. So beta minus alpha by 2 whole square or alpha minus beta by 2 whole square. Okay. So here just see this means what? It can be written, just this can be written beta minus alpha upon 2 whole square. That is, this can be written like this. So this is equals to what? Alpha to beta dx upon beta minus alpha upon 2 whole square. This is constant term, a square minus x minus alpha plus beta upon 2 whole square under square root. Under square root. Okay. Now what is this? X, a square minus x square. X is as a linear factor. So if we can put this is equals to t, then you will get same value, because this is equals to t means ds equal to dt. Here dt. Okay. After differentiation and limit will be same value. Okay, here under for different integration, indifferent integration, you can get same value. So here just alpha to beta, we know since integration 1 upon a square minus x square, just like this, dx equals to what? Sin inverse x by a as an indifferent integral. We will use the fundamental theorem. So here if x in place of x minus some constant, then you will also get like this. In place of x minus a constant, just put with that. Okay. So here we can get write its value. What? Sin inverse x minus alpha plus beta by 2. This is x in place of x, this upon a beta minus alpha by 2. This, and we have to apply limit alpha to beta. Clear? Now its value can be find. How can you find its value? Just apply the limit here. So this is equals to implies I equals to first limit beta. So sine inverse here x equals to beta. So beta minus alpha plus beta by 2 upon beta minus alpha by 2 minus sine inverse alpha. So alpha minus alpha plus beta by 2 upon beta minus alpha by 2. After applying limit is this. Now here this is equals to sine inverse what? 2 beta minus alpha minus beta. So beta minus alpha by 2. So beta minus alpha by 2 upon beta minus alpha by 2 minus sine inverse alpha minus beta by 2 upon beta minus alpha by 2. So what? Sine inverse 1 minus sine inverse minus 1. So sine inverse 1 means pi. This means plus sine inverse 1 equals to pi plus pi. Sine inverse 1, sorry, pi, not pi, pi by 2, pi by 2, pi by 2, pi by 2, pi. Pi is the answer. Okay. So, the special type of integral, definite integral. So, this type of special integrations you have to solve in this unit. Okay. So, just now I will solve simple questions. One of the simple questions, definite integrations from definite integrations. Here, just find the value of integral. Okay. Here, integration is in this class I am solving just 3-4 questions, but you have to do practice for many of the questions from your book. Just you can follow the book, just like Rival, S.K. Das, Tata Hill, and other book also, because your syllabus having 5 units and that 5 units are not integrated in a book, so you will use different type of books, okay, for getting all the topics. So here just for today's class, last question. Just evaluate 0 to 1 quad inverse. 0 to 1 quad inverse 1 minus x square plus x. Quad inverse 1 minus x plus x square. Sorry, 1 minus x plus x square dx. Just evaluate this integral. Okay. So this is cot inverse 1 minus x plus x square dx. For which technique we will use for solving these questions? Because as you will do practice for many of the questions of different type of questions from different books, you can get idea for the particular questions which technique will be suitable and which formula will be used. So just do practice for integration. Okay. For these questions, what we have to do? Cot inverse 1 minus x plus x square. So we can write, generally for solving integration, we are trying to integrand in terms of either of the well-known form, because here just cot inverse is given. So just well-known form is sin x, cos x, tan x. Best in the basic integration function format. Integral function just sin, cos, tan, just like this here. And inverse also sin inverse, cos inverse, tan inverse. So here just write first of all this cot inverse in form of tan inverse. So here we can write 0 to 1 tan inverse 1 upon 1 minus x plus x square. We can write this like this. Okay? In terms of, since cot inverse x equals to tan inverse 1 by x. Okay? Now, this is equals to I. Clear? Now here, we know the inverse trigonometric formula. Inverse trigonometric formula, that is tan inverse x plus minus tan inverse y is equals to what? Tan inverse x plus minus y upon 1 minus plus xy. Okay. So just for using this here, we can see that first of all also use the property this 0 to a fx dx equals to 0 to a f a minus x dx. By using this property here, we can write 0 to 1 tan inverse 1 upon just we can use this formula, not using this formula. Okay. Here denominator 1 minus x plus x square is this is given, so it can be written as 1 plus x minus 1 denominator 1 minus x plus x square. So 1 plus x common, so x minus x, so x common, so x minus 1 denominator. And now upper part can be written like this 1. This x minus 1 is here, this x is here, in between minus sign. So this x cancel, minus plus 1 can be written like this. So it can be written like x minus 1 upon 1 plus x minus 1. This. Just we are writing, adjusting like this. Now we will use this formula. Here minus sign, that is minus sign No, here minus sign, x minus y, in place of y, x minus 1. So x minus y upon 1 plus xy upon 1 plus xy. This is x, this is y. So here minus, that is minus. So we can write this as 0 to 1 tan inverse x minus tan inverse x minus 1 dx by using this formula. Since this and since this. Okay. Now we can solve it by using 0 to 1 tan inverse x dx minus 0 to 1 tan inverse x minus 1 dx. Clear? So how can we solve it now? Here tan inverse x we can solve. Also here it can be written in terms of like this by using, since 0 to a fx dx is equals to 0 to a f a minus x dx. Use this here. Here 0 to 1 tan inverse x dx minus here 0 to a 0 to a. Using this in second integral. Okay, so what will be the value? Tan inverse in place of x a minus x, 1 minus x, 1 minus x minus 1 dx. So here 1 cancel, minus tan inverse minus x, and tan inverse minus x equals to minus tan inverse x, that is plus. So 0 to 1 tan inverse x dx minus 0 to 1 tan inverse minus x dx, and this can be written as what? So I is equals to 2 times of 0 to 1 tan inverse x dx, because minus tan inverse minus x equal to minus tan inverse and minus plus same type of integral both, so 2 times of this tan inverse x. Okay, now it can be solved. How can you solve it? By parts. By parts integration. Just do by parts integration to using 1. By parts integration means you can write like this: 2 integral 0 to 1 into tan inverse x dx. So integration differentiation of tan inverse x is what? Differentiation here first function is differentiation of tan inverse x is what? 1 over 1 plus x square. So here tan inverse x is first function, this is second, this is first function, this is second function. So 2 of this limit here tan inverse x tan inverse x tan inverse x This will be the first value. Direct using by parts in definite integration. So first part will integration of this x, this 0 to 1 minus integration of what? 0 to 1. Differentiation of 1 upon 1 plus x square and x dx. This is here 2 1 tan inverse 1 minus 0. So tan inverse 1 minus tan inverse 0 into tan inverse 0. This minus here x upon 1 plus x square. X upon 1 plus x square means what? This is equals to t. Then what? This is equals to t means 2x dx equals to dt, x dx equals to dt by 2, 1 by 2, 1 by 2 t, 1 by 2 t, log t. So, what? 1 by 2 log of t means 1 plus x square, and just we have to put limit here 0 to 1. This is the way. So, here tan inverse 1. So, 2, tan inverse 1 means what? Pi by 4, this is 0, minus 1 by 2 log 1 log 2 minus half log 2 minus log 2 minus log 1 0 log 1 0. This. So answer is what? Finally pi by 2. So just multiply 2 to 2 pi by 2 minus log 2 log 2. So this is the value of integration. Pi by 2 minus log. What is the pi by 2 minus log? Okay, pi by 2 minus log. So this is the process for finding definite integration of a special type of integral. Just you have to remember all the technique and all the formulas. Which formula will be used? Just you have to decide first and then use. Okay. Now I will give some questions, 4 or 5 questions for your practice, and do it in your math copy, and you have to send me as a PDF file of this solution. After some days I will ask for sending. Okay. So solve the integral First question is 0 to pi by 2, 0 to pi by 2 x dx upon sin x plus cos x. Okay, first question 0 to pi by 2 x dx by sin x plus cos x, and 0 to 1 second, 0 to 1 log 1 plus x upon log 1 plus x upon 1 plus x square dx, 1 plus x square dx, log 1 plus x upon 1 plus x square dx, 0 to 1, 0 to 1 log 1 plus x upon 1 plus x square dx. Third question is just 0 to pi by 2 sin 2x, 0 to pi by 2 sin 2x tan inverse sin x dx, tan inverse sin x dx. 4 sin 2x tan inverse sin x, sin 2x tan inverse sin x dx, tan inverse sin x dx. 1 to 4 x minus 1 x minus 2 x minus 3, 1 to 4 mod x minus 1 plus x minus 2 plus x minus 1 x minus 1 x minus 2 mod of x minus 1 plus mod x minus 2 plus mod x minus 3 1 2 3 x minus 1 x minus 2 x minus 3 this. And question fifth, integration of 0 to 1 0 to 1 e to the power 2 minus 3x dx e to the power 2 minus 3x dx. Evaluate as this as a limit of sum e to the power 2 minus 3x e to the power 2 minus 3x dx e to the power 2 minus 3x dx 0 to 1 as the limit of sum. Okay, so these 5 questions are for your practice. Just you have to do all these questions and make PDF file. Okay, so do practice for solving definite integrations using properties and write all the formulas in your copy also. Okay.